Hello everyone, my name is Bhavan Shah, and in this demo we'll look at how you can provide cloud native data services using Portworx for your VMware Tanzu Kubernetes clusters running on Amazon EC2. For this demo we'll deploy a simple dev cluster with one control plane node and 3 worker nodes running on Amazon EC2. Deployment of Portworx basically automates the provisioning and mounting operations for EBS volumes to your EC2 instances, which will then be aggregated to provide persistent storage with capabilities like replication, high availability, encryption, IO profiles, etc. for your containerized applications running on your Tanzu Kubernetes clusters. So let's get started. Here we are logged into a Bastion host that's running in the same EC2 region in Amazon, which is US East 2. We already have a management cluster that's up and running. As you can see, we'll switch our context so we can execute commands against the management cluster. We'll run a couple of basic kubectl commands like kubectl get nodes and kubectl get pods, all namespaces, to ensure that everything is up and running and there are no errors before we proceed with the Tanzu Kubernetes cluster deployment. We'll use the tkg create cluster command, but run it in a dry run mode, so it generates a YAML file for us to use. So we'll specify everything that we need, the version of Kubernetes that we want the tkg cluster to be running. We are choosing 1.19. We'll select the plan, which is dev, so that means we'll only have one control plane node, and we want 3 worker nodes as part of this cluster. The YAML file that this command creates, we'll edit that file to include a couple of additional inbound rules that are needed for Portworx deployment. Since Tanzu Kubernetes cluster follows a desired state methodology, anything that we specify in this YAML file will be applied or deployed in the AWS region, and any future scale-up operations or scale-out operations will follow this desired state definition. So once we specify our TCP and UDP rules that are needed for Portworx, any future nodes that are added to the cluster will automatically have those rules and added to the security group for them. For Portworx, we need ports 9001 to 9022 for TCP and port 9002 for UDP enabled. Once we have edited the YAML file, we'll use a simple kubectl apply command to create or deploy a Tanzu Kubernetes cluster. Since Tanzu Kubernetes cluster on EC2 uses AWS Cluster API, we can use additional commands like kubectl get machine deployments, kubectl get machine sets, and kubectl get machines to monitor the provisioning of those EC2 instances. As you can see, our cluster is in creating state. We wanted to have 3 nodes as part of our deployment. So again, that's the desired state. And on the backend, Cluster API is working on provisioning those EC2 VMs and adding it to our cluster. Once the cluster is fully operational, we can do kubectl get machines and see that we have 4 nodes running, one as the control plane and 3 worker nodes. Machine deployments gives us the status for our worker nodes. We needed 3 replicas. 3 replicas are ready for us to use. So now we'll proceed with logging into the tkg cluster. So by doing the tkg get credentials command, and then we'll change the context from the management cluster to the new Tanzu Kubernetes cluster. Once we are logged into the Tanzu Kubernetes cluster, we'll again run a couple of simple commands like get nodes and get pods to ensure that everything is up and running and there are no errors in our cluster. We'll specifically look at the pods running in the kube system namespace. To deploy Portworx, we'll navigate to central.portworx.com, select PX Enterprise. We'll use the operator method for deployment of Portworx using version 2.6. We'll use a built-in etcd cluster. Since we are deploying this in AWS, we'll select cloud and AWS as our platform. And since we want Portworx to automate the provisioning and mounting of EBS volumes, we'll specify 150 gig EBS volume of type GP2. We can leave everything else as default in the network section or change things if needed. We'll select none as that's managed. We are not using a managed service from AWS. And again, we can edit environment variables and registry and image settings or leave everything as is. Once you hit finish and read through the EULA, you'll get two commands. The first is the deployment of the Portworx operator on your Kubernetes cluster. So we'll use that and deploy it against our Tanzu Kubernetes cluster. This automatically gets deployed in the kube system namespace. So we can monitor the container creation for our Portworx operator. Once the operator is up and running, we'll go back to central.portworx.com and copy the second kubectl file that will deploy our Portworx storage cluster. This YAML file automatically detects the number of nodes that are running in the cluster and deploys an equivalent number of Portworx containers using daemon sets. Once all the different components are up and running, you will have a fully functional Portworx storage cluster for your running inside your Tanzu Kubernetes cluster. In the background, Portworx is provisioning those EBS volumes of type GP2 and size 150 gig per node and mounting it to your EC2 instances and then aggregating them into a storage pool for your stateful applications running on your Tanzu Kubernetes cluster. Once all the pods and containers are up and running, we'll exec into one of the Portworx container or one of the Portworx pods to run a simple pixie-cuttle status command to look at our online nodes and the aggregated storage capacity. So we'll use a simple exec command and then do a pixie-cuttle or pxctl status command. As you can see, we have a 3-node deployment, 3 nodes which are contributing storage to our storage cluster, and the aggregated capacity is 450 gigs, which is 150 times 3. So our storage cluster is up and running. We can now use this storage cluster to provision additional persistent volumes. But before we provision persistent volumes, let's look at the storage classes. Portworx, as part of the deployment, creates a bunch of storage classes that have different settings configured for each. We'll change the default storage class from EBS to Portworx so that if our developer doesn't specify the type of storage class or the name of the storage class that they want to use, it will always use Portworx under the covers. So we'll use a couple of commands to change the default storage class. Once that's done, we'll do a kubectl get storage class again, make sure that pxdb is our default storage class. And then just to make sure that our cluster is fully functional, we'll deploy a simple application which has a Postgres component and a front-end component. So we'll deploy the Postgres YAML, wait for it to finish running successfully. So when it goes from container creating to running, and then once Postgres is up and running, we'll look at the YAML file for our front-end pod. And deploy that against our Tanzu Kubernetes cluster. So we'll use kubectl apply command and then do a get pods to look at whether our pod is up and running, get service to make sure that the load balancer type was successfully assigned. Now let's say we want to scale our Tanzu Kubernetes cluster. This is where the YAML file that we edited will help us a lot. So right now we have a 3 worker node topology. We'll scale out and change that to a 5 node topology. So right now we have 3 nodes running. We'll use the tkg scale cluster command and specify how many worker nodes we want. So in total, we want 5 worker machine count or 5 worker nodes running in our cluster. So cluster API basically creates additional EC2 instances and adds them to our cluster. And because we have used our operator based deployment topology for Portworx, as soon as those new nodes show up in the Kubernetes environment, the Portworx operator will start deploying pods and containers on top of these new nodes so they can start contributing to our storage pool. So as you can see, 2 new pods are already being created for the 2 new nodes. We'll wait a couple of minutes for the new pods to be fully functional. And once that's the case, we'll do the same thing. We'll exec into one of the Portworx pods and run the pixie-curl status command to show that we now have 5 functional nodes with an increased aggregated capacity. The reason we are doing this is to show that if a developer needs additional storage capacity, or if a developer has to scale out their Kubernetes cluster, they don't have to go back to a storage admin or a cluster admin or a cloud admin to add storage capacity. This deployment basically automates all the backend processes that are needed, which basically means that I'm increasing my developer agility. So whenever they need additional capacity, they can just scale out their Tanzu Kubernetes cluster and in turn scale out Portworx storage pool as well. That's it for this demo. Thanks for watching.